This one is number 16 from 7.2 in Applia, of course. A lot of stuff going on here. So we don't worry about it. We don't worry about how many different things there are. We know that with a big, long statement like we have in number 1, what we'll ultimately have to do is, by knowing various parts of it, break it down and make it simpler and simpler by extracting stuff. Our conclusion is k and not n. So the first thing we want to do is find k and not n in our premises. Here's an n, and it's a not n. Here's a k. Here's a not n. Oh, this is not n and f if and only if g. So just by simplification, because this is part of an and statement, we can pull this not n out. Which is nice, because now we're halfway to our conclusion. Now all we gotta do is figure out that k is true. But here's k. Stuck in that big, long, nasty statement. That's all right, we can figure it out. So what do we know? We also, from premise 2, we have this and statement, so we can pull out this not m, which will give us not m and not n, which is what we need up here, right, to start to simplify that statement. So that's from line 2 simplification. Now we're going to cram them together, because that's what we need. We know they're both true, so we can say they're both true, but we need a rule that lets us put them together in an and statement so that we can use it in this with modus ponens with premise number 1. You're going to want to say addition, but that's not addition. Remember, addition is when you add an or to something. When you put them together with an and, two lines that you already knew were true, it's conjunction. All right, now we can draw this conclusion. And how did we get that? With line 1 and line 6 using modus ponens. Remember modus ponens, if P then Q, P therefore Q. Same idea. If P, then Q. P, well then Q. That's what we did. Now we need to know if we had this not M or H, then modus ponens again would give us K and L. But we don't have not M or H. In fact, there's not even another H up here. How in the world are we supposed to get H so that we can do our modus ponens and get out of here? So only one way. Addition. So we added this not H, or I'm sorry, this H, this or H. What line in here did we add that to? Well, we added it to the line that said not M, so that's line 5. But now we have the antecedent that we needed, well, here, right, so that we can derive this conclusion. We have to write small so I don't run off the screen here. All right, so K and L from lines 7 and 8, modus ponens. Line 8 is the antecedent of line 7, so if P then Q, P, so we concluded Q, which in this case was kind of a complex statement, K and L. Almost done, almost done. Now all we have left to do is get K by itself, which should be a simple matter. That's a little logic joke, not a great one, but it's a logic joke. So we'll have K by itself, we have not N, and that's what we're going to need to get our conclusion. Line 9, simplification. Right? And now all we have to do is take K, put it together with not N. You see this at all? From line 10 and line 4. Conjunction. That is, we knew that K was true from line 10, we knew not N was true from line 4, so we know that they're both true at the same time. I hope this helps some.